Back to your favorite pre-calculus class. Good to see you guys. We're going to talk about hyperbolas today. We're going to write some equations of hyperbolas in standard form. We're going to find some asymptotes. We're going to use some properties of those hyperbolas, and we're going to classify conics from their general equations. So let's talk about hyperbolas here for a minute. You see a couple pictures there of hyperbolas. It's the set of all points in a plane such that the difference of those distances from the two distinct fixed point, the foci is a positive constant. So in other words, if you take any point, you see the picture right here, take any point on that hyperbola and you take your d2, which is back to, from that point back to one of the focus, and minus the d1, so that d2 minus d1 is k, we'll call it k, positive constant, right? Well, if I take another point on there, anywhere on the hyperbola, if we could be on the other side, right? But I go d2 minus d1, that's also going to be equal to k. Okay, so it's a fixed positive constant. That's your definition of a hyperbola. Okay, so you have these points, these focus points here. Let me put the focus in red. So we call those the focus points. You notice that it wraps around the focus there, similar to a parabola. Okay. We got our center. Okay, our center, we're going to call that HK. You see the picture on the right there at the center. And our distance from our center to our vertex is A. Okay. And then our distance from our center to our focus here is C. Okay. Then we'll talk about the distance B here in just a minute. All right, let's go to the next slide here. Here's your standard equation of a hyperbola. And you're probably, if you remember from Algebra 2, you mostly did it when your center was the origin, and you started out with this x squared minus x squared over a squared minus y squared over b squared is 1, and it looked like this where your center was the origin, right? Okay, well now we're going to move it around again, which you did a little bit of that also in your Algebra 2, but HK is going to move it around. So if your transverse axis, by the way, is between your vertices. This is your transverse axis. So if your transverse axis is horizontal, it's going to be that one right there, x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. Okay. If your transverse axis is vertical, you notice the other one there. Okay. So you have to identify which one does this thing look like for which equation, similar to your ellipses that we did in class, okay? All right, so if you can kind of keep that in mind, make sure you got those in your notes, keep that in mind as we'll jump back to this slide quite a bit as we graph these, okay? Now, if you notice here, you have some asymptotes, okay? So some asymptotes, some slant asymptotes more specifically. So you notice this dotted box that we have here. Let me erase this 2a and 2b portion. Okay. So let's say we have a transverse axis that's horizontal, as is shown here. We know our distance out from the center to a vertex. We got this distance a, right? Well, if we find our b from our equation, this is a distance b right here, okay? And that just helps us draw this box, and right through this imaginary rectangle that we have here, right through the corners are these slant asymptotes. Let me do it in red here. Okay, so you got these slant asymptotes right through the corners, and so your actual hyperbola as you go out. Okay, so let's look to the right. As your x increases, it's going to get closer and closer to that slant asymptote, both on the above side and on the below side there. Okay, so we'll sketch some of these. You'll kind of see what I'm talking about, and then we can talk about the equations as well. Okay, so example 1 here. Sketch the hyperbola whose equation is 4y squared minus 9x squared equals 36. 4y squared minus 9x squared equals 36. Well, you're thinking to yourself, well, first of all, I have to get this thing equal to 1. So that's going to be our first task here. Let's get this thing equal to 1. So let's divide all this by 36. So we got y squared over 9 minus x squared over 4 equals 1. And now you're thinking, oh, okay, let's see the y squared first over the a squared minus x squared over b squared equals 1, right? So if you're looking back at this slide previous, you're thinking right here, right? So our transverse axis is vertical. In other words, this thing opens up and down here. Okay, it opens up and down. So let's go back here. And you're thinking to yourself, let me write the standard equation below it. Y minus k, 20 squared over a squared minus x minus h, y squared over b squared equals 1. Okay, so our center on this thing, let's identify our HK. First of all, you notice that with that X, there's no X minus a number, right? So our center, our HK, 0, 0. Okay, so our center's right at the origin. That's nice. You notice our A squared is 9. So our A must be 3. Okay, so our distance back to the vertex from the center. Then you notice that the B squared is 4. So B must be 2. Okay. And you're probably wondering how you're going to find your C squared, right? Well, C squared has a formula just like with the ellipses. Okay, and if you go back, it's mentioned right here. C squared in this case is actually A squared plus B squared. So that's the relationship between A, B, and C. C squared equals A squared plus B squared. Okay, don't forget that. You go down here, skim the page a little bit. C squared is A squared plus B squared. So we can find our C here. Our A is 3. Of course, it's squared, right? Our B is 2. Oops, I already squared it. Sorry. Our B is 2. In other words, B squared is 4. So C squared is 9 plus 4. C squared is 13. C is the square root of 13. Okay, plus minus square root of 13. We know it's a distance, so it's positive. Square root of 13. All right, let's start drawing this thing. Okay, first of all, our center's at the origin, 0, 0. Our transverse axis is vertical because of the type of equation that we have. So instead of like figure 9.29, I'm thinking to myself, it's got to go like this, okay, because I have y squared first. Okay, y squared over a squared minus x squared over b squared is 1, okay? Now, how far are we back to our vertex? It's a distance of a, okay? So you notice that we have a is 3. 1, 2, 3. Distance from the center, 1, 2, 3. There's our distance A, okay? And it's gonna be kind of like this, right? Our B is 2, 1, 2. So this is gonna help us draw the box for our slant asymptotes. Our distance B here is 2, away from the center. So you can kind of draw this box. Now, this rectangle, I should say, be a little more technical about that. Okay, so our slant asymptotes are going to go through the corners of the rectangle and through the center for this hyperbola, okay? And that's going to help us draw this hyperbola a little bit better. Now I can be a little more exact with my branches, if you will, when I draw this thing, because I know I'm approaching those slant asymptotes. As x goes to positive and negative infinity, my y value is going to approach the y value of the slant asymptote there. Okay, and obviously I can plug in some points and get some points on that hyperbola. But this helps us to approximate pretty good what this thing is going to look like. Okay, so again, this is the distance A here, distance from center to the vertex. This is our distance B right here, B. Okay, helps us draw that rectangle. And now our distance C, which we haven't put on there. C is the square root of 13. That's our distance from our center to our focus. Now, if you think about the square root of 13, I'm like, well, that's between 3 square root of 9 and 4 which is the square root of 16, okay, which is approximately, in fact, let me just punch it in, 3 point whatever, 3.606. Okay, so I'm 3.6, so not quite 4 away. 3.6 away. Okay, you see my focus there? So here's my focus. Okay? And then you could name all these. So we're going to sketch the hyperbola is all what we're asked to do here. But if you're asked to figure out what the focus is here, you know, you'd write, well, that's the point 0, comma, square root of 13, since our center is right at 0. But you go up, you know, vertically, square root of 13 distance away. Our vertex, let's do our vertex right here, one of our vertices, I should say, this vertex specifically, 0, 3, and so on. Let's also do our slant asymptotes. So what's the equation, you know, let me do these in green. What's the equation of that green slant asymptote? Well, if you notice, remember for a linear line, we got y equals mx plus b, right? Slope. So our y-intercept is 0, so we just need to figure out the slope. And you notice the slope on this is we go up 3, 1, 2, 3, and we go over 2. Up 3, over 2, y-intercept is 0. That's one of our asymptotes. Of course, the other one is going to be down 3, right 2. There's the other one. Okay, and you notice that that is plus minus a over b x. Plus minus a over bx. So if you go back to this right here, it actually tells you the equation of your slant asymptotes. Let's see, where's it at? You know, maybe it's up here. What did I do with that? Or not. Oh, I'm sorry, it's on the same page right here. If your transverse, for vertical transverse axis, there we go. Okay, plus minus, and it looks kind of screwy there, I know, because they're considering HK, right? But our HK is 0, 0. So you notice the plus minus A over B X there. Okay, so there's the slant asymptote equation when your transverse axis is vertical. Transverse axis is between your vertices. Okay, let's do another one. Now sketch this hyperbola, and you're like, oh, great, it's not even close to being in the form. We're going to put this in that standard form. Okay, so we're going to have to complete the square. Let's do the x part first. So we got 9x squared, and then we got this minus 4y squared plus 8y. I'm going to add 40, so take it over to this side. Okay, now let's complete the square. So the first thing you want to do here when you're completing this square is take this 9 out of the x squared. Okay, and consider it completing the square like that. And let's take this minus 4 out of this y squared. Okay, and this should make things a little easier. Whoops, that's got to be a minus 2y. Oops. Okay, now let's complete the square here. You notice I have no bx term here. It's just like a 0x. Okay, so b divided by 2 is going to be 0 plus 0, 0. Okay, so I don't do anything with this. I'm just leaving it. It's like this, x minus 0 quantity square. So think about it just like that. Okay. Over here, though, I can complete the square. There's my b term. B over 2, negative 1, and I square it. Negative 1 squared is positive 1, so I want to throw in a plus 1 to complete the square. But what did I really add to this side? I, in all reality, actually added or subtracted 4. So I got to subtract 4 from that other side, right? To offset, I got to do the same thing both sides, right? The addition property of equality. So we got minus 4. Now I factor y squared minus 2y plus 1, y minus 1, y minus 1. Then we got 36. Okay. Now remember, for hyperbolas, I want this thing to be equal to 1. So I got to divide by 36, this whole side, in other words, each term here. And I'm going to have x squared over 4 minus y minus 1 squared over 9 equals 1. Okay? and you notice that the x squared is first. The x squared is first. So I'm thinking to myself, x minus h quantity squared over a squared minus y minus 1. K, whoops, k, putting this is your general form here, over b squared equals 1. And of course, my transverse axis here is horizontal. Okay, so I look back at my notes there, and I look at that. Okay, so what if you're sketching this thing? Okay, what would our HK be? Well, you notice the x is all alone there, x squared. So our center of this thing, HK, is 0, and our k is going to be 1. So 0, 1. There's our center now. Okay, transverse axis horizontal. All right, so our a squared, notice the a squared's got to be 4. So a is 2. Notice the b squared is 9. So b is 3. And then we know that c squared is a squared plus b squared. So c squared is a squared is 4. B squared is 9. So we got 13. Looks like the c again is square root of 13. Okay, let's put all these points on there. We got our HK, we got our center. Distance, and remember transverse axis is horizontal. So I know this thing's going to look like this and this, right? Transverse axis is horizontal. That line between those vertices. Okay, so our A length, which is 2, has got to go 2 to the right instead of up and down this time, right? And then 2 to the left. So there's my vertices. There's my vertices. That's a distance A. Distance A from our center. Okay. Let's do our distance B, which is 3. And this will help us to draw the box. 1, 2, 3 from my center. 1, 2, 3 from my center. Again, this will help us draw the box to then help us, or the rectangle to then help us draw the slant asymptotes. Okay. Let's draw the slant asymptotes right now. Okay, you can kind of see how wide this thing is. Okay, here's my vertex. It approaches the slant asymptotes. Again, you can always plot some points, but this is a pretty good way to make it look. Get a good quality approximation here of the sketch of this hyperbola. Okay, square root of 13, which is 3.606. So square root of 13, 3.6. I'm about right there with my focus. So here's one of my focus. Here's my other one, 1, 2, 3, 0.6 away, about right there. There's my other focus. Okay. So if you were to name these, let's name the vertices. You know, your vertices would be at 2, 1 and -2, 1. My focus would be, it's again square root of 13 distance away, but it's still up 1, -√13, and I'm up 1. Okay, my asymptotes. Okay, my slant asymptotes, you know, from this center, okay, from this center, I'm going up 3 over 2, okay? So, and you notice the y-intercept there is, well, you can do one of two things. You can either go point slope form using 0, 1, or since you know y equals mx plus b, and the b is 1, y-intercept is 1, there you can just count the slope again. So up 3 and over 2. So in this case, it's actually b over a x. And then it's up 1 because your y-intercept is 1. Okay? That's this one right there, right? Now the other one would be down 3, right 2. Down 3, right 2. plus 1. Okay? There's your asymptotes for that. And we should have had the equation. This was your equation, right? Oops, the square's in there as well. Okay. Find the standard form of the equation of a hyperbola having vertices at 3, 2, 9, 2. 1, 2, 3. 3, 2. 9, 2. There's our 3, 2 and our 9, 2. And asymptotes there. Negative 2 plus 2/3 x and 6 minus 2/3 x. Okay. All right, so let's think about, first of all, since you have your vertices, you know this transverse axis, which connects these things, right? The transverse axis must be horizontal. Okay, so since the transverse axis is horizontal, you're thinking to yourself, this one, right? And then you say, well, this is at the point 3, 2, this is at the point 9, 2, right? So it looks like they're 6 units away. So what would the center of this thing be? Well, it'd have to be, what, 6, 2 right there? That'd be the center. 6, 2, right? And of course, you could use the midpoint formula, x1 plus x2 over 2. Find the center, find the midpoint of the vertices, if you're not sure, right? And the vertices, so x1 plus x2 over 2, here's your midpoint formula, y1 plus y2 over 2. So that'd be 3 plus 9 over 2, and then 2 plus 2 over 2. Anyways, this ends up being 6, 2. So there's your h and then your k, right? There's your h and your k. So x minus 6 squared over, and again, I don't know yet, squared, and then 2 is your k, and then I don't know yet either. So we need to find our a and our b, don't we? Okay. Now you notice our a is the distance from the center to our vertex, right? Here's our a. Well, a is 3. So this is going to be 3 squares. Looks like we're going to have a 9 right there. And our b, let's take a look at this here. Let's look at our asymptotes. Negative 2 plus 2/3 x. Okay, negative 2 plus 2/3 x. And negative 2 plus 2, and then, I'm sorry, 2/3 x from there. So up to right 3. Up to right 3. Right? You kind of see this thing. You keep going if you want up to right 3. Here's one of those asymptotes, right? So you can kind of draw your box off of that. The other one's at 6 minus 2/3 x. So our y-intercept is 6. And then I'm down to right 3. Down to right 3. 1, 2, 3. Down to, whoops, and we took off. Draw that, took off from there. Down to right 3. Down to right 3. You notice again through the center. Down to right 3. Okay. You kind of see that there. Okay. Well, in addition to noticing, we already know our distance is a here, but what was our b distance right here? It's our b. You notice that the b is 2. B is 2. Okay, so you plug that in right there. Now the other way to figure that out is to say, well, since my transverse axis is horizontal, then I know this transverse axis is horizontal as I got this plus minus b over ax. So b over a is that slope of that thing. B over a would be my slope. Okay, you go back to the problem here. Whoops, that one. B over a. B over a, right? So b is 2. B is 2, right? 2, I already wrote that in there. A is 3. I already wrote that in right there, okay? So that's another giveaway if you want to look at it instead of making it visual there, okay? So now we got the standard form of this equation. X minus 6 squared over 9, y minus 2 squared over 4. Okay, so you take what they give you and you start filling in. You know, you got to find your HK, you got to find your A and your B, and make sure you square the A and the B. All right, last part here. Classifying a conic from its general equation, okay? Ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Well, if you have this thing in this from the general equation, all you need to figure out is the A, so the coefficient of x squared, and the C, coefficient of the y squared. If you know A and C, then that relationship will tell you if it's a circle, a parabola, an ellipse, or a hyperbola. Okay, so let's look at the first one here. X squared minus 3y squared. And let me write the general equation right above it. Ax squared bxy cy squared dx ey plus f equals 0. Okay, so we got part A here. X squared minus 3y squared minus 4x plus 1 equals 0. Again, make sure that thing is equal to 0, right? So I say, oh, well, all I need to know is A and C, right? A is 1. C looks like it's negative 3. A is 1. C is negative 3. So let's do, is it a circle? So I'm looking up above here. Is a circle? Is A equals C? Does A equal C? Does 1 equal negative 3? No, not a circle, right? Does A times C equal 0? Well, 1 times negative 3, does that equal 0? No, that's negative 3, so it's not a parabola. Does 1 times negative 3, is that greater than 0? Is that greater than 0? No, negative 3 is definitely not greater than 0. It is not an ellipse, right? Finally, is 1 times 3, 1 times negative 3, less than 0? Is A times C less than 0? I say sure. That is true. So we are apparently a hyperbola. Hyperbola. Okay, and that's how you'd go about those, each of those. Okay, you find your A, you find your C, and classify it from that. Okay, so the next one, B. Notice that your A is 1. Notice that your Y is 1. So does start off the top. Does A equal C? Yeah, 1 equals 1. So that thing's a circle. It's a circle. All right. Let's do C now. A is 1. Okay. Notice that there is no y squared. So the C value would be 0 because it's like you could have in there 0y squared. They just don't write 0y squared, right? So your C is 0. So A times C equals 0. A is 1. Our C value is 0, right? So this thing's a parabola. Parabola, okay? This is how you do it. You know, this is a quick and easy way to do it without completing the square and putting it in that standard form to identify it. D, A is 2, 3 is C. A is 2, C is 3. Which one would that have to be? Well, 2 times 3 is 6. 6 is definitely greater than 0, so it looks like this one's an ellipse. All right, well, thanks for listening, you guys. Make sure you bring some questions to class, and see you soon.